ever get completely stumped by a geometry problem? Like one of those ones that show up in the International Math Olympiad?
Yes, definitely.
The ones where, like, even if you had Euclid himself sitting next to you, you'd still be lost.
Yeah, those are pretty rough.
Well, what if I told you that today we're going to dive into something that is even better than having Euclid as your tutor?
Hmm, I'm intrigued.
We're talking about an AI called AlphaGeometry2?
AG2.
AG2 that's taking the IMO by storm.
Yeah, I've heard about this one.
And it's solving some of the toughest geometry problems out there.
That's right, the IMO.
The International Math Olympiad is famous for being like the most challenging high school math competition in the world.
Oh, absolutely.
It brings together these brilliant young minds from every corner of the globe, and they have to tackle these incredibly intricate problems.
And geometry is like a cornerstone of the IMO, right?
Oh, for sure.
I mean, these aren't your typical high school geometry problems. We're
No.
talking about problems that would leave most people just scratching their heads.
So how does an AI even begin to like wrap its circuits around something this complex?
It's pretty amazing, actually. So AlphaGeometry2 builds upon its predecessor, AlphaGeometry, AG1, as some people called it,
AG1, okay.
which already had a pretty impressive track record. It had a 54% solve rate on IMO geometry problems from the years 2000 to 2024.
That's already pretty good.
It is, but AG2 takes it a step further, a whole new level.
So what's the secret sauce? What makes AG2 so special?
Well, it uses this thing called a neuro-symbolic approach.
Okay, I've heard that term thrown around. What does that mean exactly?
So basically, it combines a language model, which you can think of as like a supercharged predictive text engine,
Okay.
with a symbolic engine, which is a system for logical deduction.
So it's like having a creative brainstormer
Yes,
paired up with a super strict logician.
exactly. That's a great way to put it.
They're working together to crack these problems.
And that's led to some really significant improvement.
Okay, let's talk improvements.
One of the major limitations of AG1 was its language.
Oh, really?
It just couldn't fully express all the nuances of these really complex geometry problems. So they gave AG2 a much richer vocabulary. It's called an expanded domain language. That allows it to really grasp and work with concepts like moving points, finding angles and ratios, those find X problems,
Oh, yeah, those get me every time.
and even solving those tricky locus problems.
Locus problems. Those are the ones that make even Caesared mathematicians sweat, right?
Exactly. Even some of the IMO contestants struggle with them.
So this expanded domain language essentially opens up a whole new world of problem-solving possibilities for AG2.
That's right. AG2 can now tackle a category of problems that completely stumped its predecessor.
Okay, so that's the language upgrade. What else is new and improved?
So they also beefed up the symbolic engine. It's called DDR2. And it's not just stronger, it's also way faster.
Okay, how much faster are we talking?
Over 300 times faster than the previous version.
300 times, that's a serious speed boost.
It is, and they achieved that through some clever algorithms and switching to C++ implementation.
C++ makes sense.
But what I find really fascinating is how DDR2 handles these things called double points.
Double points. I'm not familiar with that term. What does that mean?
So sometimes you'll have a problem where the same point is described in two different ways. Like it might have two different names but the same coordinates.
Interesting.
And AG2 is smart enough to recognize that
Okay.
and use it to its advantage by reframing the problem to find like a more elegant solution.
So it's not just faster. It's also thinking more strategically.
Exactly. It's approaching the problems from a more sophisticated angle.
I like that. A strategic AI.
Now, one of the most innovative features is the Advanced Novel Search Algorithm. They call it SKES1.
Okay, another acronym. Break this one down for me.
So imagine a team of AI detectives,
Oh, okay.
each one exploring different solution paths at the same time.
Right.
And they're all sharing their findings with each other.
So it's like a collaborative effort.
Yeah, instead of trying one path at a time, AG2 is exploring many possibilities in parallel.
So much more efficient.
Exactly. This makes it much faster at finding solutions, especially for those really complex problems where there are just tons of different avenues to explore.
That's a really cool approach. So we've covered the expanded domain language, the stronger and faster symbolic engine, and this team of AI detectives working in parallel. What was that fourth major improvement you mentioned?
Yes, the enhanced language model.
Right.
Remember how we talked about the language model being trained on a massive data set of geometry knowledge?
Yeah, like feeding it a geometry textbook.
Well, AG2's language model is even more powerful.
Okay.
It's been trained on a data set of over 300 million synthetic theorems.
300 million, that's mind-boggling.
It's like giving it access to a massive library of geometric wisdom.
So what can it do with all that knowledge?
Well, it can generate auxiliary points like its predecessor,
Right?
but now it can also generate entire proofs.
Whoa, hold on. So it's not just finding the answer, it's actually understanding the logic behind it.
Exactly. It's demonstrating this potential for language models to solve problems independently.
That's incredible.
You know, what's also interesting is that the researchers found that the choice of tokenizer,
Tokenizer.
the way they break down the language for the AI, didn't really have a huge impact on performance.
So what does that mean?
It means that we might be able to adapt existing language models for math without having to build completely new systems from scratch.
So we could repurpose existing technology.
Exactly. It's a pretty exciting development in the world of AI and mathematics.
It is. I'm really curious to see how this plays out in the future.
Me too.
So we've talked about all these impressive upgrades, right? The expanded domain language, the supercharged symbolic engine, the team of AI detectives working in parallel, and this enhanced language model that's like practically a geometry guru.
Yeah, it's a lot to take in.
It is, but the big question is, how does AlphaGeometry2 actually perform?
Well, it lives up to the hype, that's for sure.
Does it really? Give me the numbers.
AlphaGeometry2 was able to solve 42 out of 50 IMO geometry problems from the years 2000 to 2024.
42 out of 50.
That's right, an 84% solve rate.
84%, that's incredible.
And it's significantly higher than its predecessor.
So it really is a major step forward.
It is, and get this, it even surpasses the average score of IMO gold medalists.
Wow, so we're not just talking about an AI acing a test.
Right.
We're talking about an AI that is potentially outperforming some of the best young mathematical minds in the world.
It really makes you wonder what it means to think mathematically.
It does. If an AI can solve these incredibly difficult problems, are we even testing the right skills at the IMO?
That's a very valid question, and AlphaGeometry2's success doesn't stop there. It was actually a key part of a system that achieved a silver medal at the 2024 IMO.
Wait, hold on. An AI contributed to an actual IMO medal?
It did. It was part of a hybrid system that combined AG2's strengths with human input.
That's amazing.
Yeah.
It really highlights just how far AI has come in tackling complex mathematical reasoning.
And to really push AG2 to its limits, they also tested it on a set of 30 super challenging problems. It's called the IMAS-L AG30.
IMOSL AG30, another acronym. Break this one down for me.
So these are essentially IMO-level problems that were considered for the exam but didn't quite make the cut.
So like almost made it to the Olympics of geometry problems.
Exactly. And even on these incredibly tough problems, AG2 managed to solve 20 of them.
So it's safe to say that AG2 is a force to be reckoned with in the world of geometry problem solving.
I would say so. But what does this mean for the future of mathematics?
That's the big question. Is AI on the verge of replacing human mathematicians?
I don't think replacement is the right word. I see AI more as an invaluable tool for mathematicians. Like, imagine having a superpowered assistant that can help you explore mathematical concepts at lightning speed, test out different approaches, and maybe even stumble upon solutions that you might have missed.
So enhancing human capabilities rather than replacing them.
Exactly. It's about collaboration and augmentation.
You know, I remember reading about how AG2 solved one of the problems from the 2024 IMO using a really unconventional approach.
Oh, yeah. Problem 4, right?
That's the one most human contestants tried to solve it using trigonometry and other complex methods. But AG2 found a much simpler solution by constructing an auxiliary point.
That's right. A point that wasn't explicitly given in the problem, but helped connect the dots in a surprising way.
It's like the AI saw something that human mathematicians with all their training and experience just didn't see.
It's fascinating, isn't it?
It is. It's both fascinating and a little bit unsettling.
I know what you mean. It shows that AI isn't just mimicking human thought processes. It's offering a fresh perspective, a new way of approaching problems that could lead to all sorts of exciting discoveries.
Speaking of exciting discoveries, I'm curious about what's next for AlphaGeometry2 and AI systems like it. Where do we go from here?
Well, there are so many possibilities. One obvious next step is to expand AG2 to handle 3D geometry problems.
That makes sense. Right now, it's like AG2 is playing on a flat surface. Imagine what it could do if it could explore the depths of 3D space.
Exactly. Another challenge is to make these AI systems more robust and adaptable. Right now, they excel at solving problems that are clearly defined and fit neatly into their pre-programmed language.
But the real world is messy and unpredictable.
Exactly. So how do we teach an AI to handle the what-ifs and maybes that are so common in real-world problems? How do we get it to think outside the lines of a perfectly constructed geometry problem?
Those are some big questions.
They are. And another area that's ripe for exploration is how AI can be used to enhance the learning and teaching of mathematics.
Now, this is where things get really interesting for me.
Yeah.
I'm all about finding ways to make math more engaging and accessible.
You too.
Could we see AI tutors that can personalize instruction, identify where students are struggling, and even adapt their teaching style to match each student's needs?
That's definitely within the realm of possibility. Imagine an AI tutor that can analyze a student's work, pinpoint exactly why they're getting stuck, and offer targeted feedback or explanations that resonate with their learning style.
It would be like having a personal math coach available 24/7 that truly understands how you learn best.
And think about what this could mean for teachers. AI could handle tasks like grading and providing basic feedback, freeing up teachers to focus on individual students and provide more in-depth guidance.
So it's not about replacing teachers, it's about empowering them to be even more effective.
Exactly. And let's not forget about the potential to make math more engaging. AI could be used to create interactive learning environments, gamify concepts, and even generate customized practice problems that challenge students without overwhelming them.
I love the idea of gamifying math learning should be fun, and AI could help us tap into that sense of play and exploration that's so important for deep understanding.
Absolutely. Now let's shift gears and talk about research. How do you think AI, like AlphaGeometry2, could impact the world of mathematical research?
Well, it's easy to imagine AI taking on some of the more tedious tasks that mathematicians face, like checking proofs or performing complex calculations.
Right.
That would free up researchers to focus on the bigger picture, the creative side of mathematics.
I agree. AI could act like a tireless research assistant, crunching numbers and exploring different mathematical concepts with incredible speed and efficiency.
This could accelerate the pace of discovery, helping us unlock new insights and push the boundaries of mathematical knowledge.
And AI could also help bridge the gap between theoretical mathematics and practical applications.
Okay, how so?
Well, there's so many mathematical concepts that have potential uses in fields like physics engineering and computer science,
Sure.
but translating those concepts into real-world solutions can be challenging.
So AI could help us close the loop, connecting abstract mathematical ideas to real-world problems and solutions.
That's the hope. It's about using AI to not only advance our understanding of mathematics, but also to harness its power to solve real-world challenges.
It's an exciting time to be involved in the world of mathematics and AI.
It really is. And for our listeners who want to see AlphaGeometry2's brilliance in action, we've included links to some of its most creative solutions in the show notes.
You'll be amazed at the elegant and sometimes unexpected paths this AI takes to solve these challenging problems.
It's truly remarkable to see what it can do.
Well, that wraps up our deep dive into the world of AlphaGeometry2. It's clear that AI is changing the landscape of mathematics in profound ways, and as these systems continue to evolve, who knows what incredible discoveries and innovations lie ahead.
Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.
Yeah, it really is mind-blowing to think about all the ways AI could be used in mathematics.
Right?
I mean, we've talked about AlphaGeometry2 solving these super complex problems, even like outsmarting human mathematicians in some cases.
Yeah, it's pretty incredible.
But what I find really fascinating is what this means for the future. Like, how does this change the way we teach math? How research is done? How we solve problems in the real world?
Those are like the million-dollar questions.
They really are. And while we can't, predict the future with 100% certainty,
Of course not.
it's clear that AI is going to have a huge impact on all those things.
Definitely a game changer.
So let's start with education. You mentioned the possibility of, AI tutors that can personalize instruction.
Yeah.
What would that actually look like in a classroom?
So picture this right.
Okay.
You have a student struggling with geometric proofs. Instead of just marking their answers wrong, an AI tutor could actually analyze their work and figure out why they're getting stuck.
So it's not just about identifying the error.
Right.
It's about understanding the student's thought process.
Exactly. Like, are they missing a key concept? Are they applying the rules incorrectly?
And then providing feedback that's tailored to their specific needs.
Precisely. The AI tutor could then offer personalized hints or explanations, maybe even present the same concept in a few different ways until it clicks for the student.
It's like having a one-on-one tutor who really gets how you learn.
Exactly. It's all about making those connections.
That's incredible. I mean, that level of personalized learning could really help students build a much deeper understanding of math.
For sure, instead of just memorizing formulas and procedures, they're actually developing that conceptual understanding.
It's about making those connections.
And think about the implications for teachers.
Oh, yeah. What about them?
AI could take over some of the more time-consuming tasks, like grading and providing basic feedback,
Right.
freeing up teachers to focus on individual students and offer more in-depth guidance.
So it's not about replacing teachers.
Not at all.
It's about giving them the tools and time to be even more effective.
Exactly. It's about empowering teachers to do what they do best.
I like that, and we can't forget about making math more engaging.
Oh, for sure.
I mean, learning should be fun, right?
Absolutely.
And AI could help us do that, like creating interactive learning environments, gamifying concepts, even generating customized practice problems that challenge students without overwhelming them.
That's a great point. Gamification is huge right now, and for good reason, it taps into that natural sense of play and exploration.
Which is so important for learning.
Couldn't agree more.
Okay, so let's shift gears a bit and talk about research.
Sure.
How do you see AI, like AlphaGeometry2, impacting the world of mathematical research?
One thing that comes to mind is AI taking on some of the more tedious tasks,
Oh, yeah, like what?
like checking proofs or performing complex calculations, things like that.
That would definitely free up time.
It would give researchers more time to focus on the bigger picture, the more creative side of mathematics.
So AI as like a super efficient research assistant.
Exactly. It could crunch numbers, explore different mathematical concepts with incredible speed and efficiency.
And that could lead to all sorts of new discoveries, right?
Absolutely. It could accelerate the pace of discovery, helping us unlock new insights and push the boundaries of mathematical knowledge.
It's like having a brainstorming partner that never gets tired.
That's a great analogy. And you know what else? AI could also help bridge the gap between theoretical mathematics and practical applications.
Okay, explain that one to me.
So you have all these mathematical concepts, right?
Yeah.
With potential uses in fields like physics engineering, computer science.
I see.
But translating those concepts into real-world solutions can be tricky.
Right. It's one thing to understand the theory. It's another to actually apply it.
Exactly. And that's where AI could come in.
Closing that gap.
Yeah, connecting those abstract mathematical ideas to real-world problems and solutions.
That's a powerful idea, using AI to not only advance our understanding of mathematics, but also to actually use it to make the world a better place.
I think that's the ultimate goal, right?
It's definitely an exciting time to be in the world of math and AI.
For sure. And for our listeners who are curious to see what AG2 can really do,
Yeah.
we've included links to some of its most creative solutions in the show notes.
You'll be amazed at the elegant and sometimes totally unexpected ways this AI solves these challenging problems.
It really is remarkable what it can do.
Well, that brings us to the end of our deep dive into the world of AlphaGeometry2.
It's been a fascinating journey,
It has, and it's clear that AI is already having a profound impact on mathematics.
and it's only just the beginning.
As these systems continue to evolve, who knows what incredible discoveries and innovations lie ahead.
Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.